So, good afternoon here from Wetzigau. Hello and welcome to a new webinar. Today we are focusing on the metal and steel industry. My name is Nicholas Oppenberger, Product Manager at UWT, and as always, I have support by my side. Today it's Alexandra. Hello, Alexandra.
Hello, everybody. My name is Alexandra Woloschin, and I'm Area Sales Manager from the Export Department. Today, we will focus on ferrous metallurgy.
Alexandra, I know you have a lot of experience in the metal and steel industry. Yeah, you were traveling and visiting many steel plants all over the world. You saw many applications. So I'm really happy that you will share your knowledge today with us. Maybe you can point out at the beginning 3 things. So what are the typical challenges in the steel industry? What are the raw materials and how they are extracted? And then steel production, what are the typical processes?
Thank you. All over the world, you will find factories for the production and processing of metal. The leading countries in metallurgy are China, India, and Japan. Let's start with the industry requirements. Just a moment, please. But now, industry requirements. Everyone knows that in metallurgy, there are extreme process temperature. We can offer you sensors up to 1200 degrees. We have specialized solutions for aggressive material. You can have our sensors made of special alloy steel with FFKM sealings. Or, for example, we can coat your sensor completely with PTFE. The next point is the issue of mechanical load. Every sensor range includes a heavy-duty version. We can offer you sensor for mechanical loads up to 1200 Newton meter. Alternatively, you can use our Nivo radar. A wide range of extremely dust materials are used and found in the metallurgy process. To meet this challenge, your sensor came equipped with a high degree of protection by way of the housing design, up to IP68, for example, in the NivoBob. And on the processing side of the sensor, we also ensure full protection against dust. Naturally, no one wants to be constantly replacing the sensor in a processing plant. And so, our sensors offer completely reliability and durability. In fact, one of our longest running devices, a RotoNivo, has been in constant use since 1982, which I think makes it older than many of the participants in our training session.
Yeah, it's even older than me. So, old guy.
Equipment and metallurgy plants must, of course, be explosion-proof. Our equipment is certified in countries all over the world. In addition to explosion protection, we can offer you sensors which meet the seal requirements. And of course, in the unlikely event of something going wrong, we can support you by offering you a wide range of spare parts for all our products, so that you can simply and easily repair the device yourself. We can support you through this by way of easy to understand self-help videos on our website that will take you through all repairing processes step by step.
Yeah, thank you, Alexandra, for the industry requirements. So there are many challenges our sensors, our measurement devices are confronted with. But now let's move on to the process steps, raw material extraction, and then how steel is made, and also have a look at the success stories, what we already solved in the metal industry.
Thank you. From the rock to metal, there are the following steps: mining, raw material handling, costing and rolling, and finishing. Let's now look at our success stories to each step. Mining starts with geological exploration and ends with the delivery of raw material. Most iron ore mining operations use the open pit method, where minerals drilled into the rock and let the ore burn material loose with explosive. To mine metallurgical coal, which will later be turned into coke, it's usually necessary to sink vertical mine shafts to access coal, which is deposited in layers or seams underground. In the processing stage, the mined materials is transformed into usable raw material. For iron ore, this involved crushing the ore and then concentrating in the different ways. For example, mining, flotation, or magnetic separation. What complex tasks we solved with our sensors? Let's see. Mining with stowing is an environmentally friendly way for coal mine. Stowing materials could be sorted as chemical reaction materials, solid refuses from coal mine, and natural material for stowing. The customer had to know the level of stowing material in exhausted mine. We had to use the available ventilation pipe for the measurements. The measurement range was only 30 meters, but it was completely underground and a depth of 100 meters. How we this problem solved, Nicholas?
Yeah, thank you for the description, Alexandra. So this was a pretty interesting application you pointed out. So we had to design a special version of our NivoBob 3200. So what did we do? We exchanged the standard sensor wide and put it on a longer rope. So the rope had a length of 100 meters, and this was necessary to come through the ventilation pipe. So with the long rope, we were able to come through the pipe, and then we could start the measurement in a depth of 100 meters underground, although the sensor was mounted over ground, what we can see on the slide here. And then in a depth of 100 meters, the measurement range was 30 meters. And this, as you know, is no problem for our NivoBob 3200 with the S-tape version. And here you can see the mounting position on the right side on this ventilation pipe. And another important feature was the brushless motor for this application. So as you know, we have two different motor versions, the standard motor and on the other hand, the brushless motor. The brushless motor has several advantages. First one is the measurement speed, so faster, so the sensor wide is faster driven up and down. Second one, and most important for this application, was the stronger motor. So we had a greater tractive force, so it's increased from 800 Newton to 3000 Newton. This is important, for example, when the sensor wide gets covered with material and the motor is then able to put out the sensor wide from this coverage. And as you know, when you're underground, you don't want to have a covered sensor wide. Lifetime brushless motor is way higher than the standard motor, so we have a lifetime of up to 60,000 hours here. So we can guarantee that the NivoBob will work for a long time in this application. Nice application, interesting application, solved with a special solution of the NivoBob.
We can offer every time a special solutions. The extracted minerals need to be transported for processing. For this transportation, conveyor belt is used. One of our customers in Costa Rica needed to control conveyor belt system responsible for transporting rocks and powder into a hopper. The abrasion and dusty environment were a tough challenge together with the constant high flow speed of the material, which required a reliable response. Which sensor can be used for this application, Nicholas?
Yeah, you already see it in the video. So we use the Rotonivo 3004 for this application, and I do also have it here in my hands. Here with the extension tube around the shaft, so as an additional protection for the shaft, that there are no damages due to this heavy material. We do also have a special sealing design here made out of PTFE, to avoid any dirt coming inside the extension or around the shaft. And yeah, robust design, long lifetime in those applications. And for this application, one specialty, what you can see what you saw in the video, that the sensor was mounted at the bottom, but it worked as a full detector. So as soon as the material reaches our sensor, our vane, it's blocked, and then you get a signal, and this signal indicates that the cone of the material, of the filling material, has reached a critical height, and this then stops the conveyor belt and the transportation of new material. So we can protect the conveyor belt from any damages due to a too high material cone. So mounted on the button, but it worked as a full detector. So pretty interesting application here.
Thank you. Let's go on later. Just a moment.
Yeah, again, the video, what you saw here, mounted on the button, but working as a full detector.
Exactly. Sometimes it is necessary to install the probe at such an angle so as to protect it from the filling material. Here you can see 3 examples of such protection. That is different between the sensor of our RotoNivo line.
Yes, we do offer different RotoNivos. This is what you can see on this slide. So the standard version 3100 with just the shaft, no additional tube around the shaft to protect it. Then we have the 3003 version with an increased stability due to the extension tube around the shaft. And then we do have the tension version, what I have here in my hands. So also pretty heavy product here, and you can see this tension version here, and this is then for greater stability for pretty heavy materials to protect the shaft, and it's still working, the rotary pedal rotation. And we have a stability of 1,200 Newton meters. So pretty much force that can work on the sensor. And also when you lift it, it's pretty heavy, and you can feel the robustness of our sensor here. So when it comes to heavy materials, the RotoNivo can also be a solution due to our wide variety, wide product portfolio. So many different versions here.
Thank you. Often is it not enough just to detect the filling, but it is necessary to know how much material is inside of the container. Here you can see our NivoBob and NivoGuide in high narrow silos containing raw material and iron ore with use NivoBob and NivoGuide.
Yeah, this was, now you can see the slide what Alexandra already described. So we had a few problems here, but yeah, 2-level transmitter you can use for silos with coal, kalkstone, or iron ore. One is the NivoBob. Here we can focus on the high dust content. We have a great feature here. This is called the tape cleaner for our NivoBob 3200 tape version. Tape cleaner to get rid of any dirt and dust. So here you can see a short animation and then also a video of how the tape cleaner works and how it cleans the tape. You can see the dirty tape, and when the tape is carried in, all the dirt gets away from the tape here due to the tape cleaner. And it's also a nice feature that our tape cleaner drives in and out the socket pipe. So this then, again, you have a self-cleaning effect of our tape cleaner due to this in and out drive. The dirt gets thrown away and nothing is inside the mechanical chamber, so it always stays clean. Here again, the best solution for dusty environments with the tape cleaner. And what we do also have is the Nivo Guide, a second technology. Guided wave radar technology can also be used in those silos for solid application. I have it in my hands here. So here again, robust design of the coupling. We have a large diameter of the rod or the rope. It's also available as rope version up to a length to 75 meters. And this rope is also very stable, diameter of 6 millimeters. So yeah, pretty robust design and perfectly sensor for those applications.
Thank you. The next application is a thickener or concentrator. Here it is necessary to measure the interface of sludge in the water. With frequently changing parameter of the measured material. The product is a slurry of water with tailings. It is like a sand 80 microns. This medium is very aggressive with a lot of different acids. How can we protect our sensors against aggressive materials, Nikos?
Yeah, again, quite challenging application. Here, we had to design a special solution again for the NivoBob with coating. So what we did, we coated the sensor white with halar, and we also had to design a special sensor white. Here on the picture in the middle, you can see the halar coating for the aggressive material. So with this coating, it's quite resistant against this aggressive material. And we also implemented a stainless steel tape roller, so to make it more robust and more resistant against the aggressive environment in this application. So here again, special solution for a challenging application.
The next step is raw materials. Once mined, the materials need to be transported. Iron ore, bearing material, and metallurgical coal is typically delivered to steelmaking sites by large ocean-going ships or using good trains. Raw material are stacked according to their grade by gene machines called stacker reclaimer. This machine picks up the raw materials and deposits them on conveyor belts using constantly rotating buckets. To make steel in a blast furnace, coal must first be turned into coke. Coke has a dual role in the steel making process. First, it provides the heat needed to melt the ore, and second, when it's burned, it has the effect of stealing the oxygen from the iron ore, leaving only the pure iron behind. In the cooking plant, coal is heated in the absence of oxygen to 1250 degrees. These remove any impurities in the coal, resulting is coke, which is porous substances that is nearly to carbon. The Sinter plant turns iron into a sinter, which is the optimal product for the blast furnace. Sinter is made by burning a mix of iron ore, powder, fluxes, and recycled substances from the steel plant. What complex tasks have we solved with our sensors? Let's see. And how are the materials loaded to the ocean-going ships? Here, you can see an interesting application. A shuttle conveyor belt travels all the way inside of maritime container and fills the container with material. The point level is to detect when the material reaches the max fill level and instructs the conveyor belt to back away until no level is detected and continue filling, and so until reach the end of the container. We have a limited space to install our sensor, and it has to be reliable and easy to maintain and be completely dust-proof. Which sensor is suitable for these applications, Nicholas?
Again, very interesting application and interesting task for our sensor, to control or position a shuttle belt What we did here, or what we used, was the RF Nivo 3200, the heavy duty version, because of the heavy bulk material, and also our sensor, the RF Nivo, is quite sensitive. So we have a high sensitivity. The sensor has not to be covered fully with material to react, but it's enough when the material comes in, near the sensor. So then it already reacts. So, and this was the main point why we could use the sensor for the positioning of the shuttle belt. Also, heavy duty version, robust design. So as you said, long lifetime and fast reaction time. Another great feature is the quick calibration. So you only have to push one button and then the sensor is perfectly calibrated for the application, and also automatically. So you don't have to go through a setup, but just click one push button and then it's automatically calibrated to the application.
Let's take a look at the stacker reclaimer. What sensor can be used for the slowing boom?
For this application, it's more or less the same as I described before. Here we used the RF Nivo 3100. So standard version, not the heavy duty version. Here the standard version with a rope extension was the solution we go for. Here open air application, so maybe it will rain, maybe it can snow, whatever, but there is no need to recalibrate our sensor. It's not influenced by any environmental changes, so that's why the sensor worked perfectly for the application. And I have those two sensors here. So on my left hand, I have the heavy duty version, so you can see the more robust design. It's a greater diameter. And on here, my right hand, I have the standard version, so it's a little bit smaller in diameter, and not so robust. So this one is made for the more heavier products here, and this one for the standard application. So again, one principle, but two different versions for different applications.
A sinter plant supplies a blast furnace with a sinter, a combination of iron ore, fluxes, and coke. These fine-grade materials are mixed in the correct proportion and heated in vacuum. There you can see a component storage silo along conveyor belt and an electrofilter. Let's see what sensor can we use there. Our presentation is a little bit slower than we want.
So now here for this application, we can use the Nivo radar. So here again, it's mounted near the conveyor belt, and we do also have a short video. This is how it looks like. And if you want to measure continuously the height of the rocks here, you can use the Nivo radar. 80 gigahertz technology, so small beam angle. It can be installed in narrow spaces, so perfect for those applications. It's also waterproof, so IP68 stainless steel housing, so also in open air application, no problem to install the Nivo radar.
I hope it will be now faster. Okay, then you can see a long conveyor belt, electrofilter, and a big silos. It was a sinter plant. Okay, and on this step, you can see electrofilter. The particular challenge there is to install a technology which withstands the temperature up to 600 degrees and which can be installed despite this space and only horizontally. The filter ash is really sticky. What can we use for this application?
Yeah, here we used our rotary pedal again. So this time the Rotonivo 3004. So the one you can see here, it's temperature resistant up to 600 degrees Celsius. It has a special sealing design here to protect the shaft and yeah, avoid any dirt coming inside the shaft. We have this cooling element here to keep the electronic cool, and also different extension lengths to be able to install them in long sockets also from the side. So the Rotonivo 3004 high temperature version is one of the best solutions for the electrofilters. We installed many of them in the filters. They are working perfectly, and also for a long time, even though we have sticky material buildup, but the rotating pedal is not influenced by any buildup, it just keeps on rotating. So no problem if we have any buildup here around our paddle.
Okay, let's move on the next step. Steel is an alloy of iron with typically a few tenths of % of carbon. Before iron ore can be used, oxygen must be removed from it. In this step, the various ingredients are loaded in the blast furnace. At the output of the blast furnace, we get cast iron and molded slags. The cast iron has to be transported from the blast furnace to the next step. For example, to the oxygen furnace. What can be used for such transportation? A torpedo car is a type of railroad car used in steel mills to haul molded pig iron from the blast furnace to begin the process of primary steel making. The thermally isolated vessels designed to endure extremely high temperature, as well as keeping the metal in a molded state over extended periods of time. The customer uses our NIVO radars for the monitoring of the loading process. Here you can see the protective sheets that protect the roof from the temperature. Of course, our sensors are designed only for 200 degrees. And of course, the temperature of the measured material is about 1,500 degrees. The left picture shows you the view through the observation hatch. The distance to the hot surfaces is very, very large. How does it work, Nicholas?
Yeah, you already mentioned the high temperature. So when you think of 1,500 degrees Celsius, pretty hot, molten iron, pretty hot. And our NIVO radar is made for temperatures up to 200 degrees Celsius. But what we had here, we had a protection sheet over the torpedo car, and this was mounted over the torpedo car. And on this protection sheet, we could then install our unit. So the heat was cooled through this distance, through this air distance, and near our unit we had around 150 degrees Celsius, so no problem. And we also had this observation hatch on the left side, on the left picture, and through this observation hatch our NIVO radar could measure the level of the molten iron in here. So again, interesting application. Due to the narrow beam angle, we were able to easily measure through this observation hatch, so we did not get any false signals or anything, so reliable measurement. And also for applications, what you might not at first think of the NIVO radar, but with this installation, with this type of installation, it was easily possible to measure also molten iron here in this steel production plant.
And of course, at any metallurgical plant, there are a huge amount of liquids. Let's have a look at only one example. The customer needed to measure the level of moody water tank. The installation should be done in a bypass chamber. The measured distance was 1,800 millimeters, and our sensor has to be installed in a tube with a diameter 6 inches. What can we offer there, Nicholas?
Yeah, you already see it on the slide. We used the NivoBob, and as you said, yeah, water is always present in a steel plant. So high temperatures, they need to be cooled down. And for this, we use water. And then we also have muddy water. This application was perfectly made for the NivoBob. We had a bypass tube. So this is, yeah, a good installation position for the NivoBob because it's perfectly made for narrow spaces, bypass tube. It has a high accuracy, a fast reaction time, what you can see on the video, how fast the capacity changes when we when water is when we have a lower water level, then the capacity goes down, it raises, then it's fastly raising, so fast reaction time. And also we do have a PFA coating, so when it might be a little bit more sticky, PFA coating avoids buildup around the rod. So accurate measurement results, and NivoBob is a good solution here for the application when it comes to a bypass installation, muddy water. NivoBob is working perfectly here. And I think this was the last application for today. It was only a short extract of what we solved in the metal and steel industry. If you want to know more, want to have more application, please visit our homepage. We have an application database where all our, or a lot of, not all, but many applications we solved are there to find in the application database. And for today, I hope that we could give you a short overview of our products, of the application which are waiting for our products in the steel industry. We have a wide variety of technologies, of different versions for the different application, for the different challenges. And I hope that you enjoyed our webinar and got some helpful information.
And we are waiting for your requirements.
Yes, you do. So thank you.
Thank you.
Bye-bye.